Okay, so in the last section, we saw how to choose an estimator or machine learning model for the problem that we're working on. Do we have a regression problem? Do we have a classification problem? And we followed this flowchart through and we tried out a bunch of different models such as linear SVC and ensemble classifiers, aka the random ensemble classifier or the random forest classifier. That's it. And now in this section, we're going to have a look at, or actually, let's revisit our what we're covering list. So we've ticked off this end-to-end Scikit-learn workflow. Yep. We've seen getting the data ready. Yep. We've seen choosing the right estimator / algorithm for our problems. Now we're up to here. 3. Fit the model / algorithm and use it to make predictions on our data. Now we've kind of actually seen this. Well, we've seen the first half. We've seen fitting the model. But we're going to have a look at both. We're going to look at fitting the model and then use it to make predictions on our data. So what we might do is go 3 is fit the model / algorithm on our data and use it to make predictions. Wonderful. And then under here, we'll probably do section 3.1 is fitting the model to the data. Now we've kind of got some code that'll help us out for this already. And again, I'm not a fan of copying and pasting code, but in the interest of time, because otherwise we'll just literally be retyping everything in this cell. But I trust you might have already done that. So if not, you can retype it out. I'm going to copy that in here. And the main line we're concerned about here is the fit. So if we type in here, we go fit the model to the data. So I'll just re-step through what we've got here. Because we didn't type it out, we broke our rule. But that's all right. From sklearn.ensemble, import random forest classifier. This is saying, hey, sklearn ensemble library, import the random forest classifier model. We've set up a random seed. We've split our data into X and Y. So X is the feature variables or the features or the data. They're different names. So we might put in here, or actually, maybe up here. X equals features, feature variables, data. They're just different names for X, and Y equals labels or targets or target variables. So different names for. This is just so if you see where you're out and about, see different names for these two. X and Y are common variable names that you'll see in Python, but these are different like names that they'll be referred to, right? And so what is fit doing when it goes through here? So let's have a look at X. We're being visual here, right? Not getting stuck in the theory of things. So y.head. This is our X and Y. And what are we passing at? Well, we're passing at the training data and training X and training Y to our classifier. So this is the fit function. This is what we're concerned about. Fitting the model to the data. What does fit actually do? Well, when we pass X and Y to fit, it will cause the model to go through all of the examples in X, the training data in our case, and see what their corresponding Y label is, and try to figure out the patterns that lead, so the different combinations of numbers here, what leads to having a 1 as a label, or a 0 as a label in the case of the bottom end of this, y.tail. Yeah, or a 0 as a label. That is fit in a nutshell, right? And how the machine learning model, in our case a random forest classifier, how this does this is going to be different depending on the model you use. And explaining the details, so remember, all of these green ones here are different machine learning models. And explaining the details of each and every one would require an entire textbook or a much longer video course, right? For now, to become a practitioner, to start applying machine learning code, the most important thing you can remember is that it's kind of similar to how you would figure out patterns if you had enough time. You'd look at the feature variables in X, the age, the sex, the cholesterol. I'm not sure actually what the rest of these are. They're just different health attributes. And you'd see what different values of these lead to different values in Y. 1 for heart disease or 0 for not heart disease. Right? This concept, regardless of the problem, is similar throughout all of machine learning. So during training, which is what the fit function is, another term for fit. So we want training. Okay, that's why we're using training. Training machine learning model. The model is going to find patterns here. And then during testing here, or when a machine learning model is in production, it's going to use the patterns. So use the patterns the model has learned. That is the crux of all of machine learning, right? The way we become practitioners of this is starting off by first diagnosing what problem we're working with and then coming in and finding a model. Now, you can dive in as deep as you want to actually figure out the nuts and bolts of what a random forest classifier does or what a random forest regressor does. That may be a bit of an extension we work on in the future. But for now, that's the crux of it, right? If you want to figure out what a machine learning model does, it takes some data, it finds patterns, and then it figures out, or in supervised learning, it figures out how those patterns relate to the labels. That's it in a nutshell. If you wanted to, you can dive as deep as you like into each of these models. Not focusing on that for this course. Remember, our focus is to write machine learning code rather than dive into the theory. If you like, I'll leave some extra resources on some deep dives into the random forest model, which is the one we've been using. But for now, we've finally seen, or we've heard what the crux of machine learning is, finding patterns in data. We're going to see how we can, this is 3.2, make predictions using a machine learning model. So now that our models have learned patterns in the data by calling the fit function, how can we use what it's learned to make some predictions on data the model hasn't seen? We'll have a look at that in the next video.